Alright, before we move on to talking about bonding between atoms, let's take a quick review of a diagram of an element as listed in a periodic table. So you'd have element right here, normally a rectangle. The top you'd have a number. Say right now we're doing helium, and a value. Usually that's decimal on the bottom. Right here, this is known as the atomic mass. Which is the number of protons plus number of neutrons. So, which is protons plus neutrons. This is the element symbol. And this is the atomic number, which is essentially the same thing as the number of protons. Alright, let's continue. So, next concept we must look at is that let's get is is that the formation and the function of molecules depend on chemical bonding between atoms. Let's define chemical bonds. Okay, chemical bonds are defined as interactions between the valence electrons of different atoms. Atoms are held together by chemical bonds to form molecules. A covalent bond occurs when valence electrons are shared by two atoms. I'll be talking about valence electrons soon. Of the covalent bonds, non-polar covalent bonds occur when the electrons being shared are shared equally between the two atoms. So, for example, if you had say, let's see what we could do. If you had an element here, an element here, non-polar covalent bonds would be oxygen, 2, right? This is oxygen right here. This is the first molecule of oxygen, second molecule of oxygen, and they're being shared equally by a double bond. Also, we could look at hydrogen, elemental hydrogen, which exists as a two molecules. That'd be a single bond, two molecules of hydrogen, and that would be nonpolar because this the polarity is canceled out on each side. If we look at atoms vary in their electronegativity, a tendency to attract electrons have a covalent bond. For example, oxygen is highly electronegative, meaning oxygen might want to sort of take the electron of another element when it binds. We'll go into that a little bit later in this course. In polar covalent bonds, one atom has greater electronegativity than the other, resulting in an unequal sharing of the electron. For example, let's look at water. Water exists in natural form as H2O. H2O also could be called dihydrogen monoxide. It exists as one molecule of oxygen, with 2 molecules of hydrogen. This is also could be so-called Mickey Mouse molecule. So here, because oxygen is electronegative, the charge here would be a positive, and here it'd be also negative. So it'd be pulling the electrons here. Electrons would be spinning around here more often than they would be over here. This is slightly positive. Remember, this is not like a clear distinction. It's just more positive. It's not clear cut as positive. It's not like you have electricity. You know, it's either going to be a resistor or capacitor or currents. With chemicals, it's just slightly more negative or slightly more positive.